Hi, I am Dr. Orijit Shaha, Associate Professor of B.P. Poddar Institute of Management and Technology, Kolkata, India. Today, I am going to discuss about basics of amplitude modulation. In this lecture, we want to cover the topics time and frequency domain representation of amplitude modulation, envelope of amplitude modulated signal, modulation index, critical under and over modulation. In this slide, we want to discuss about time and frequency domain representation of amplitude modulated waves. The amplitude modulated signal is shown here as phi amt equal to AC cos omega ct plus mt cos omega ct. The spectrum, which is basically the Fourier transform of the amplitude modulated signal, that is given as half m of omega plus omega series plus m of omega minus omega c plus AC by 2 delta omega plus omega c plus delta omega minus omega c. Now to sketch the phi amt, we sketch AC plus mt and minus AC plus mt and fill in between with sinusoids of the carrier frequency. The AM signal and its envelope is shown in the figure. In the first case, AC is large enough so that AC into 1 plus mt is greater than or equal to 0 for all t. AC means the peak amplitude of the carrier signal, whereas in the second case, that AC is not large enough to satisfy this condition. So in the first case, the envelope has the same shape as mt, basically riding on the DC of magnitude AC. In the second case, the envelope shape is not empty. Basically, some parts are getting rectified. Now, if we want envelope detection to take place for amplitude modulated waves, then we have to follow certain conditions. What are the conditions? The first condition is that for all t, AC plus mt should be greater than equal to 0. If mt is greater than equal to 0 for all t, then AC equal to 0 also satisfies the above condition. But it is not always the case. So we have to follow the above one, that is AC plus mt should be greater than equal to 0. Let MPT be the peak amplitude, positive or negative, of mt. So this condition now requires AC should be greater than or equal to MPT. Thus the minimum carrier amplitude required for envelope detection is MP. What is modulation index or depth of modulation? It is a very important parameter. The modulation index is defined as mu equal to MP by AC. Now already we have got an idea what is AC and what is MP. MP is the peak amplitude of the message signal or modulating signal, and AC is that of the carrier signal. So it is basically a ratio which is given by the above equation. For envelope detection, because AC is always greater than or equal to MP, and because there is no upper bound on AC, it follows that mu, that means modulation index, should lie in between 0 and 1. It may also be expressed as a percentage, where the percentage of modulation is simply the mu multiplied by 100%. Different types of modulations are now shown. For critical modulation, what is the condition? Condition is that AC equal to MP or mu equal to 1. So the waveform is shown over here. Now we want to show the under modulation case. The condition for under modulation is AC is greater than MP or mu is less than 1. It can be any value. Here we have just added an example with modulation index equal to 0.05, where the maximum amplitude is 2 volt, DC of 40 volt is added, and the waveform is shown. Here in this case we want to show the over modulation. The condition is AC less than MP or mu is greater than 1. The example we have shown over here, modulation index is 2. So we see a part of the modulated signal is getting rectified, which should not be the case for envelope detection. So regarding modulation index, what we understand or what are the conclusions we can draw is the envelope of the AM wave has a waveform that bears a one-to-one correspondence with that of the message signal if the percentage modulation is less than or equal to 100%. And if the percentage modulation exceeds 100%, then the modulated wave is said to suffer from envelope distortion. How we can experimentally determine the modulation index is shown here. When AM signal is displayed on oscilloscope, modulation index can be computed from Vmax and Vmin. The Vmax, Vmin, everything is shown in this figure. You can see over here. The peak value of the modulating signal is basically Vm, that is equal to Vmax minus Vmin by 2. And that of the carrier signal is Vc, and that is Vmax plus Vmin by 2. So what is modulation index? Mu equal to Vmax minus Vmin divided by Vmax plus Vmin. We want to derive the relation between modulation index and modulated signal amplitude. From the previous figure, we see that Vm equal to Vmax minus Vc, that is equal to Vc minus Vmin. So by definition, mu equal to Vm by Vc. This mu may be written in two equivalent ways. What are they? Mu equal to Vmax minus Vc by Vc, or mu equal to Vc minus Vmin by Vc. By adding these two equations, we can see mu equal to Vmax minus Vmin by twice Vc. And subtracting equation 2 from equation 1, we get twice Vc equal to Vmax plus Vmin. So substituting these values, we get finally mu equal to Vmax minus Vmin divided by Vmax plus Vmin. So far we have dealt with simple modulating signals. Now we want to find out if it is a composite signal, then what will be the modulation index. Now composite signal means what? It is a signal which is made up of more than one modulating signal. So we can say if instead of a single tone, the message signal MT consists of several frequency components, say F1, F2, F3 up to Fn, each of these will produce a corresponding upper and lower frequency components. Let us consider mu1, mu2, mu3 and up to mun. It represents the modulation indices for the individual components, and their values depend on the amplitudes of the frequency components relative to the carrier amplitude AC. Then the overall modulation index mu of such signal MT is given as mu equal to root over of mu1 square plus mu2 square plus mu3 square up to mu square. So finally we came to the end of this presentation. What we have learned here is time and frequency domain representation of AM, the envelope of AM, different modulation index, and what is critical under and over. I want to thank you all for watching this video. Try to solve these questions, describe the condition for envelope detection, interpret modulation index, predict the value of modulation index for envelope detection, describe how you can determine modulation index from waveform of amplitude modulated signal, and list the modulation index values for a composite signal.